Hello, receiving teachers, receiving students, and ATs. Thank you. You may be seated. Okay, before we go into our lesson for today, I would like a selected group to come up and present what they have prepared on the chart that I asked you to work out your answer from our previous activity. So which group would like to come up and present their working out on the whiteboard? You can bring your chart with you and explain from the chart together with the working out. So ATs, can we have groups to come and present? At least 2 students to come and present what your group members have prepared. To the receiving teacher, you can select volunteers among the groups that you have in your class to present what they have prepared on the chart using the blackboard, or if you have any whiteboard, they can do so. Let's have group 9 to come and present what they have come up with. You others, check to see if you have the same working out and you have labeled or wrote the measurements according to where it's supposed to be on the diagram. Okay, from the previous lesson, you were given an activity to complete for homework. And you were to write the different measurements on a cylinder. Okay, this group have drawn their cylinder. Check yours if you have drawn your cylinder like the one we have on the chart. And your measurements that were given, the radius was? What was the radius? 6.4 what? Centimeters. How about the height? Okay, 15.9. Did they wrote the measurements in the correct parts of the cylinder? Yes or no? Okay? Very good group. This is group 8. They have wrote the measurements on the parts where it's supposed to go. We have the radius from this end to the center of the area of the base of this cylinder, which is in the form of a circle, and they have written 6.4, which is correct. The height from up here down this way, 15.9 centimeter. Now let's have a look at the working out. The formula they used was V equals AH, where area is equals to pi r squared, equals pi times 3.2 times 3.2 times 15.9, equals 3.14 times 6.4 times 15.9, and they have their final answer as 31,437.04. Anything wrong with this working out? Yes? Who can tell us? Shall we make correction together on the board? Who's going to give us or tell us the mistake that is shown from this working out? Loud and clear?
Cubic centimeter.
Cubic centimeter is missing the unit. Okay, that's one. What's the other one? Diana?
The measurements are wrong.
The measurements are wrong. Can you quickly come and correct the working out that is on the board? What measurements are you referring to? Okay, so you're working out on this end so that the other friends of yours can see where she went wrong. Okay, let's check. Can you now see where the mistake is? Okay, why did she multiply 3.14 times 6.14 times 6, or 3.14 times 6.4 times 6.4? Can anyone tell us the reason why? Eddie, loud and clear quickly.
She multiplied 6.4 because it's radius.
Okay, because it is the radius. We are in the formula for calculating the volume of a cylinder, we use pi r squared. And in this case, the radius was given as 6.4. We cannot divide this again into 2 because unless it is the the diameter 6.4, then you can break it up as radius and you will have 3.2. Probably that was what our friends had in mind. In this case, we have 6.4 square as the radius. And they have worked out their answer, and their final answer was 2044.96 cubic centimeter. Okay, that is correct. Can we round it off to the nearest whole number? Yes. Now, what would be the rounded answer? Put your hand up. Okay, we seem to be having Eddie all the time. You others, what do you think? Round it off to the nearest whole number. Okay, Eddie?
$2,045.0.
Okay, let's give him 5 big claps. 2045.0 cubic centimeter. That's the final answer that you should have as you're working out. Okay, we have it as a whole number. He has given us the answer as 2045.0. The whole number to have now is 2045. So that's the answer from your previous activity. Okay, looking back at the formula, PRISM, the volume, the formula for calculating PRISM is V is equals to A times H. Okay, in our previous lesson, we learned another rule combining the area of the cylinder, which is area is equals to pi r squared. Where A is, that is the area of the base of this cylinder given as a or drawn as a circle. So the formula for calculating the area of a circle is pi r squared. So we learned that the formula for calculating the volume of a cylinder now changes to V is equals to pi r squared H. Are we following? That's from our previous lesson. That was the formula that you were to use here. That's the calculation for that, to join this together. We were using the term also shaded area. Let's do away with this phrase. We go straight to the formula by using area is equals to pi r times the height, which is H. Okay, for today's lesson, our lesson topic is volume of a pyramid. Okay, in order for us to learn the formula for calculating pyramid, we got to know the relationship between prisms and pyramid. What is the formula for calculating prism? Formula for calculating volume of a prism? V is equals to AH, or A times H. For today, it will be a bit different. Volume for prism is V equals AH. For pyramid now, we are going to be using the fraction part of it, which is 1/3. There is also a difference or a relationship between the prism and a pyramid. We will come to see that using the two concrete materials that I have in front. what you are going to be achieving towards the end of this lesson, you are going to be identifying the formula for calculating the volume of a pyramid and also recognizing the relationship between a pyramid and a rectangular prism. But in this case, it is a pyramid and a prism, because any prism have different shape of the base. It doesn't have to be a rectangular only, but any prism at all. So we are going to be seeing the difference between a pyramid and a prism. So that's what you are going to be learning throughout the lesson. Okay, here we have the definition for pyramid. What is a pyramid? Following through, a pyramid is a shape which has the base as polygon and the faces as triangles, which meet at the top as vertex, called the apex. Okay, here up front, I have a concrete material of a pyramid. Okay, it has a polygon base. This is what we mean by polygon base. What is the shape of this? The shape of this pyramid, the base of it. Okay, it is in the form of a square. So it is a square base pyramid. The faces of this is in the form of a triangle. The points meet at the top. What is the name of this vertex? The lines here are the vertex, which is called the apex or apex. Okay, apex. This is the top part of this pyramid. So this sample here, pyramid, is called a square base pyramid. Are we following 80s? We have another one here. The base is in the form of what? Triangle. And the faces are also in the form of triangle. And it has an apex also. Okay, example of a pyramid is on the screen. Polygon base, triangular faces, and the apex. I've shown you using the concrete material, and it is also on the screen. We will be learning the formula now on how to calculate the volume of a pyramid. So look at the formula very carefully. The formula is expand a little. We have V is equals to 1/3 times A times H. 1/3 it derives or it relates to the shape called the pyramid. The relationship now together with that would be volume of a pyramid is 1/3 and the volume of the prism is, or the formula for calculating the volume of a prism is, who can tell us? Volume of a formula for calculating the volume of a prism would be, Hela?
Volume equals height times area times height.
Okay, that is the formula for calculating prism. For pyramid, we have V is equals to 1/3 times A times height. That is the formula for calculating pyramids. So remember the formula, you might be confusing yourself. Formula for pyramid, that is on the screen. Let's have a look at this activity example. How many shapes do I have in this diagram? How many shapes? 3. Okay, there are 2. One is given in a dot line, and it is in the form of a rectangular. Inside the rectangular, we have a pyramid. Okay, there is something common that is shared between the two shapes. The relationship between a rectangular pyramid prism that I have and the pyramid. Can we see that common relationship between those two shapes? Yes or no? Yes. Okay, who can tell us? Quickly pass the mic.
The base.
Okay, the bases are common. Very good. The two shapes, the pyramid and the rectangular shape, they all share the same base. So the base is common. There's one more. There's one more common area that we haven't made a mention of. We have the common base in those two shapes. What's the other one?
Height.
Okay, very good. They have the same or common base, and also, he said the height. What about the height? What about the height? I can hear answers from students. Okay, why did you say height? Height, when you say the word height, it doesn't really give us the clear picture. Okay, like our Francis said, the bases are common. What about the height? I know you can give the answer.
The height is the same.
Okay, the heights are the same. From the bottom up here and also from the center of the pyramid up to the apex here, the heights are the same. So that is the relationship between a prism and a pyramid from the diagram that I have. So I have the base given. Area of this would be, area of the base of this shape would be, we have 2 times 4, and the height would be 12. Area of the base is always referring to this part here, the cross-section area that we have. That is the area of the base. Height can be this one horizontally or it can be vertically. So this is how it's supposed to have in a formula manner. V is equals to a third times area of the base times height. A third times 2 times 4 times 12. Simplify if possible. 3 into 3 goes 1. 3 into 12 goes 4. Equals 1 times 2 times 2 times 4. The final answer is 16 cubic centimeter. That is just to show you the clear picture on how to calculate the volume of a pyramid using the formula. Are we clear now on how to work out the formula of a volume of a pyramid? 80s? Are we clear? Yes. Any questions? Because you will have only one activity to work on as your exercise. Then we are going to have a volunteer to come up and show the working out on the board. So get yourself ready. Here I have an activity for you. Calculate the volume of this pyramid correct to 1 decimal place. Measurements are given as 2 centimeter, 2 centimeter, 8 centimeter, and 17 centimeter. Using this measurement, I'd like you to have that in the given formula for calculating the volume of a pyramid. To the receiving students, your activity is on the screen. Use the formula for calculating pyramid now to work out your answer. Make sure your answer should be to 1 decimal place, your final answer. You can work in pairs. Make sure you calculate your answer correctly. You are dealing with part of the formula is given as a fraction. Simplify if possible to make it easy for you to calculate your answer. If you cannot, don't force the numbers. Have you finished? What was your answer after this? What was your answer after this? Okay, shall we go through the correction together now? Let's have some answers. Let's have some answers to this activity. To the receiving teacher, you can select a student to give your answer. Okay, we'll have, what's your name? Joseph. Quickly pass the mic. He will give us the answer and then we are going to check from the screen if you have the same working out with the answer compared to what I have prepared on the PowerPoint.
9.7 cubic centimeter.
Loud and clear.
9.7 cubic centimeter.
9.7 cubic centimeter. Raise your hand up if you have the same answer. Hands right up. Okay, very good. Let's check from the screen. Okay. We have an answer that is on the screen. 1/3 times A times height. 1/3 times 8 times 2 times 17. Okay, I have multiplied all these three together. 1/3 times 272. And my answer that I came up with after dividing 3 into 272 is 90.66. And you were to round it off to the nearest, not whole number, sorry, to 1 decimal point. I have 90.7 cubic centimeter. Did we have the same answer? Yes. Put your hand up if you have the same answer. Okay, you are given credit for that. There are some students that came up with 9.7. Do you see where your mistake is now? Okay, that is the correct answer for your activity. You have extra activities that are in your worksheet. You can continue doing that. If you want me to check that, you can bring your books for me to correct. So you have all the time to complete those exercises. Receiving teacher, you can also ask your students to continue doing the extra activities that they have in their worksheet books, or you can give them, prepare some and give them to your students. So that is how to calculate the volume of a pyramid using this formula. We have the summary that is on the screen. Pyramid is a solid with a polygon base, meaning is the side crooked. Polygon means the lines are straight. A polygon face, but it's supposed to be the polygon base, and a point at the top called the apex. What do we call these sides here? They are shown as this front here. They are the vertex. What is this? Face of a triangle. So a pyramid is made up of a polygon base, triangular faces, and also all the vertices meets up at the top, which is called the apex. Have you finished? The formula for calculating the volume of a pyramid is V is equals to 1/3 times A times H. Keywords that you have come across in our lesson for today: polygon base, triangular sides or faces, and the apex. In your next lesson, you have a new lesson topic which is on volume of cone. To the receiving teacher, that is the next lesson topic, volume of cone. Materials needed, take note, examples of cone shapes, cut out pictures of cone from magazines or books. If you are not able to make one, you can cut out pictures of cone. Is that clear, 80s and the receiving teachers and students? Take note of this. With that, this has bring us to the end of our lesson. Thank you, 80s and receiving students, for your participation all throughout our lessons.